Hi everyone, welcome to the lecture series on applied mechanics. The specific topic here is the centroid of simple and composite areas. Let us look at a centroid for simple areas like a triangle with a base B, height h. Right? The area of this triangle will be half into B into h, and the centroid will be somewhere here. At from this rectangle point it will be 1/3 of B in x coordinate, because when trying to read the centroid of this one, we have to see the reference axis. This is reference x axis, this is a reference y axis. The x coordinate of the centroid is measured along the x axis. So that is along x axis b dimension, so b by 3. The y coordinate is along the y axis, which is here the dimension h, so h by 3. So b by 3 along x direction, h by 3 along y direction, y axis. So this is somewhere here the centroid x bar comma y bar. Now if you take a rectangle, the reference axis is x, taken area into positive first quadrant, width of b and height of h. Area of this rectangle is b into h. Now the centroid of this area somewhere here, which is along the width, it is somewhere half, along height somewhere half is here. So this will be coordinate x bar comma y bar. The x bar will be half of the b, the y bar will be half of the h, because x bar is measured along the x axis, y bar measured along the y axis. Right? Now let us take a circle. Now important point is my reference axis passing through origin, the center of the circle. So my area of the circle is pi r square. The centroid lies at the center of the circle. That's important, x bar y bar. Since the origin happen to be same, so x bar becomes 0, y bar become 0. Now we take another area, simple area, common area, which is semicircle, and your reference axis is passing through the center, y axis and x axis here. Since another half is not there, so the area of this circle is pi r square by 2. Right? This is the area. Then area A. The x bar, that means from this point along x axis here, the centroid lies somewhere, because along x axis because symmetric, right? So along x axis centroid remains at the same point. But right, that is why x bar is 0. But along y somewhere here. So that this distance in y axis is called 4r by 3 pi. From this center vertically 4r by 3 pi for the semicircle. If I have a quarter circle, right, the reference axis x axis y axis passing through center, right, this is the quarter of the circle, right. So area becomes 1/4 of the pi r square. The centroid along x axis is this distance, is x bar, along y axis is the y bar, which is again 4r by 3 pi, and y bar also 4r by 3 pi. Of course there is a derivation for all these centroids detail, but we are here to remember now these centroids for simple areas. So this ready-made, the centroids of common areas or simple areas can be used for composite areas. So let us look at one composite area called a kind of a dam or a retaining wall. So in order to find centroid of this particular composite area, this is cross section area. That dam may be having a lot of length in the perpendicular to the computer, right. So now this area will be divided into two common or simple areas. First of all, we take the reference axis. So this will be my origin, x axis, and this is the y axis, and divide this two area into two parts. One being this rectangular area number 1 identified as 1, and second area being a triangle. Then you make the dimension of this particular first area, which is 10 by 100. Second area, total 100 minus 30 will be a 70, and 40 minus 10 will be a 30. So the dimension of this triangle area is known to me, and remember all dimensions are in millimeter. Now make a tabular form. Write down the first column as the serial number of areas, the area of each area, the identified number, and simple areas centroidal. From reference axis, very very important. This is from reference axis. This is important. Okay. So this x bar, xi or yi, I am writing this from the reference axis. Okay. So now let us take area 1, which is 100 into 10, 1000 millimeter square, and this particular area xi means along x axis, where is centroid. So along x axis, this area is up to only here. So half of this is your 10 millimeter. So half of 10, which is 5 millimeter. Now along y axis, again being rectangle, half of the dimension along y axis. Along y axis, I have 100 millimeter. So 100 by 2, which is 50 millimeter. Of course, from the reference axis, this is reference. Y direction reference becomes x. X direction reference becomes y axis. So now next area is your 2, which is triangular. The area becomes half into 30 into 70, which is 1050 millimeter square. Then now the reference x bar for this triangle area, for this triangle, centroid lies somewhere along x axis, 1/3 of this base, 1/3 of the base somewhere here. But I want to measure from the reference, that is y axis. This much distance I am looking for. That means this 10 plus 1/3 of the 30. So 10 plus 1/3 of 30, which is 20. Similarly, now y axis. So for y axis, y bar or yi, my reference will be x axis. Since the area touching x axis, I have to measure here, this direction, and from here it is 1/3 of the height. Height is 70, 70 by 3, which is 23.3. So that's all. I got only two areas here. So total area becomes 2050. So the formula for, because these two areas are distinct areas, discrete areas, so the total, the common centroid will be x bar equal to a1x1 plus a2x2 by a1 plus a2. If it is not discrete, continuous, then we have to take integration. So a1 1000, a2 is 1050, x1 is 5, and x2 is 20. By total area, I get 12.68. From here, 12.68. So this is a 10 somewhere here. Along the x-axis somewhere here, right? Along this axis, somewhere 12.68. But what about y-axis? a1 y1 plus a2 y2 by a1 plus a2. So I know y1, this is y1, this is y2. So by substituting here, I get 36.72. That means along the y-axis, 36.72. Total 100, roughly it is 1/3 of the total height, roughly, little more than that, something like this. So this will become my centroid of the So somewhere here. So this will become a centroid of the total composite area. Right? Very simple. So here A1, this is A2, and this is X1, this is X2, this is Y1, this is Y2. And use this formula and find out the centroid for this composite area. Now let us see what if I remove area from the given cross section. Okay. So now I have a same dam, but there is a circle cut there. So in the concrete I can have a hole across the length of along the length of the dam for some maintenance purpose. Now how will I find out the centroid now? The centroid will not be the same point, it will shift, right? Slightly left hand side and slightly upward. So let us see that. So now I will have reference axis x axis, reference axis y axis, all dimensions given, in the radius of the circle also given here. And now I divide the areas. Now I have three areas. One is the rectangle, second is a triangle, third is a circle. Now, so use the table form. First area as usual, rectangle, and x1, y1 remains same, doesn't change. Second area is triangle, area of a triangle, x bar and y bar does not change, x1, y1. Then third one is the area of a circle, which is pi r square. Now thing is, I am writing here minus pi r square, minus because I have to remove this area, because effectively the area is not there, so minus pi r square. Now x1, the centroid of the a simple area, from where? From the reference axis, because I am looking for xi, right? I have to see from y axis, right? From here till the centroid. So up to here I have anywhere 10, plus from up to here, this is the radius of the circle, which is 5. So 10 plus 5 is 15. I hope understood. Now y, vertical, since the center is at the radius, which is 5, and this circle is touching to x axis, so directly 5. Okay. So now simply use the formula a1 x1 plus a2 x2. Actually plus a3 x3 I can write. The area is not a positive but negative, so I will write minus. By a1 plus a2 plus a3, the area is minus, so I substitute minus a3. So instead of substituting as a3, so I am writing minus a3. So you don't have to put minus of minus plus, not required. Should not do rather. So substitute this value a1, a2, a3, x1, x2, x3, y1, y2, y3. So I get 12.6. Okay. And y again minus here, very important, because this area to be removed, so minus a3, here minus a3. So here get 37.6. So the centroid coordinate is 12.6, 37.6. So you must have seen previously the 12.6 and 36. So if you see previous question, what was the centroid? 12.68, slightly right hand side, 12.6, little came down, but here shifted up. Okay. Now let us look at the next question. Using the method of composite areas, calculate the centroidal coordinate of the plane region. So let us say this is a kind of C, but not symmetric. And then I should have a reference axis, very important. If nothing is there, better to keep the area into first quadrant. The first line and this here bottommost will be the x axis and this is y axis, if nothing is given. But if it is given, so we don't have a choice. Now I have to find area of this shaded region. So I should make the number of areas, like this much rectangle, one area 1, and this is another small rectangle which is area 2. Here forms another triangle, area 3. Here forms another rectangle, area 4. Here forms another rectangle, area 5. So I got 5 areas. So just fill in the table the area xi and yi. Let us say area 1, area 80 into 30 or 30 into 80, 2400 millimeter square area. Now x bar, xi, that means centroidal for this rectangle simple area from along the x-axis, that means reference is y. So half of this dimension, 80 by 2, so 40. Now y, so along the y-axis, along the y-axis how much dimension? 30, so 30 by 2. But what is the reference? So this area I have from where? From reference x-axis, right? So that means this 30 plus this 90 plus 30 by 2. 30 plus 90 plus 30 by 2 is 135. Now second area, which is small rectangle, which is I understood here, total 60 is given, this 30 gone, so remaining this is 30 and this is 20. So area is 20 into 30, right? Again x-axis, so this is 20 by 2, 10. In y-axis 30 by 2 is there, but from where? From the bottom, that's important, from here. So from here how much? 30 plus 60 plus 30 by 2. 30 plus 60 plus 30 by 2. It is 105, is very important. Now third area, which is triangle. The triangle area, what is area of the triangle? Half into b into h. Half into 30, this is 30, this is 60, right? Now x bar, so along x-axis, from here 1/3, but reference is from the y-axis. So this 20 we have to add, 20 plus 1/3 of 60, 20 plus 1/3 of 60, so 20 plus 20, 40. Right? Now y-axis, yi, that means from the x-axis total distance from here. So that means from, and now I have to measure from the x-axis from the bottom, I have to go somewhere here. So from this side 1/3, but from this side is 2/3, very important. So that means 30, this 30 plus this 60, right? 30 plus 60 plus 2/3 of this 30. Okay, and remember this, from this side is 2/3, from the perpendicular side it is 1/3 only. It's 110. The fourth area, which is simple rectangle, right? Area is 20 into 60, 1200. Now xi, from here xi, that means this distance 20, so half of 20, 10. So y, half of 60, 30, but from where? From the x-axis. So that means it's 30 plus 60 by 2, 30 plus 60 by 2, which is again 30 plus 30, 60. Now the fifth one, the fifth area is touching both axes, right? Area is 80 into 30, x coordinate half of 80, 40, y coordinate half of 30, which is 15. Now it is simply a matter of adding all the areas, which is 7500. So formula for the centroidal coordinate will be a1x1 plus a2x2 plus a3x3 plus a4x4 plus a5x5, because 5 areas are there, by sum of all areas. By substituting this, so multiplying this, I get 2406, 2,46,000 by 7,500 gives me 32.8 millimeter. Similarly y, I can this write as summation of ai yi, ai yi, a1 y1, a2 y2, a3 y3, a4 y4, a5 y5. So I get this, which is equal to 79.2. So this I will mark from here. I can mark from here the coordinate somewhere x direction 32.8. That means this is 80. So middle is 40 somewhere here in this on this line. But y axis how much? Along y axis it is 79.2, roughly 80. So total is how much? 90 plus 60, 150. So little more than half somewhere here, little more than half. So this will be my centroid, this centroid of the section. Very simple. So like this slowly you can do that. So let us look at another area problem. Very simple is this semicircle is there. So now dimension, this semicircle has a radius of 30 millimeter and it is forms another rectangle which is 60 by 30, because this is the radius, this is radius which is given as 30. So this is 30 and height is 60. This forms a triangle which base is 30, height is 60. So simply make a triangle. And remember one more thing here, very important, that my reference axis is given here passing through center of the semicircle and it is touching the end of the rectangle. This is important. Now I cannot take my own reference axis. I have to use this as the reference axis. Okay, this is the origin. So most of area is left hand side. So I will have x coordinate to be negative. That means this is a positive first coordinate, all this is negative second coordinate x, right? So the x coordinate will have negative value. So let us see that. So write down the properties area xi yi. First area is half of the circle, semicircle, pi r square by 2. And now from reference axis, where is x coordinate, which is exactly in the middle, that means 0, right? So 0. The y axis here, from here it is 4r by 3 pi, but from where? It is from here. But what I need to know from the reference axis, which is 60 plus 4r by 3 pi. So which is 72.7. What is the next area? Which is rectangle. Right? Rectangle, which is 60 into 30. What is xi? Xi from in x-axis positive side, but my area is negative side, so my x coordinate will be negative side, right? So that means half of this 30. So minus 30 by 2, which is minus 15. So y cannot be negative because this x-axis, now all area is positive y direction. If area is downwards, I would have given negative y. But now my area is positive side, so y will be for this is from here half of the 60, which is 30 millimeter. Now third area, which is triangle, area is half into b into h, half into 30 into 60, and from x-axis means along x-axis, reference of y-axis, so from here it will be 1/3 of this radius, right, 10, along y-axis. Now it's not from the perpendicular side, but I have to measure from this side, it will be 2/3 of this height. 2/3 of this height. This height is 60. So 2/3 of this is 40. So once I know, so simply write down the total area here, which is 4117 and 3.7. So the area x bar will be a1x1 plus a2x2 plus a3x3 by a1 plus a2 plus a3. Now I am not reducing area, but only thing is I have one coordinate, x coordinate as minus. So which is x2, right? x2 is minus. I have to simply substitute this as a minus. That's all. So here like this. So a1 x1, a2, x2, x2 is minus. So that way I'll subtract this. So I got minus 4.4. That means my x coordinate is this side at a distance of 4.4 in the left hand side, somewhere in the line like this. Now what is the y coordinate, which is centroid y coordinate? a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3. So here in the y direction I don't have any negative value, so all positive here. So I get a 46.9. So total height is something around 60 plus, 90. So 90 is a little more than 50%, half of that, somewhere here, right? So something like this will be my centroid. Okay, so this is the centroid, minus 4.4 and 46.9. So for your practice, I want to give you some problems. So find the centroid of this composite. This is reference x-axis, this is reference y-axis. And find the centroid. Similarly, for this temple-like 2D problem, with respect to x and y-axis, this is x-axis, this is y-axis. Don't worry about this, whatever given. This centroid actually, you will find out. This y bar you are going to find out. So that's what centroid means. This is x bar, y bar. So he is indicating, but distance not given. You need to find out. Similarly, a problem like this. Find out the centroid of this figure with respect to x and y. Y is exactly coming in the symmetric middle. And similarly, this anti-symmetric C section, asymmetric, and asymmetric I section. With respect to this x and y, find the centroid, and this is again same C section, and this is inverted T section. Find out with respect to this centroid x and y. You can take the reference, maybe here you can take a reference x and transfer. This is centroid, and this is a different kind of channel section for this also. Reference distance is given to this axis, so this becomes my reference axis, and this reference axis, and this is Z section, reverse Z section, normal Z section, and my x axis you can take. Now since here x and y mentioned but not given exact axis, so you can choose anything. Maybe you can take this to be a x axis, y axis like this, and this could be x axis, or you take here this could be x axis and this is y axis to make everything positive side. That's your choice. That's your choice. So you can make whatever convenient to you. Thank you.